All right, there's a hexagonal pyramid and prism for you, and then we drew the nets of these as well. Of course, one of the triangular, the one that looks like a star, is for the pyramid, and one of the rectangles is the prism. And the surface area of a sphere with a diameter 20, of course, you'd have to find the radius, which is 10 meters, and then use the formula to solve that. There's our objective, though. I can find the volume of composite shapes and spheres. Take 30 seconds and write that down, please. All right, volume of composite shapes and spheres. I mean, spheres are, I don't know, part of these composite shapes. And we've already found volumes of spheres. However, one of the shapes that I guess we haven't really gone over in great detail is prisms. And now I know we've gone over surface area prisms, though. So you just find the surface area of each shape and then add those all the surfaces of those areas together. But we're looking at volume now. Now for volume of prisms, though, okay? For the most part, we should be looking at two different types of prisms, specifically prisms. We're going to look at rectangular prisms. It's a very common type of prism. To find the area of a rectangular prism, that's just length times width times height, right? And a rectangular prism, I don't know, it's something like this, right? This kind of shape. Hopefully yours look prettier than mine, but something like that, okay? But also triangular prisms like this. Okay, so you can have a triangle like this one, and then one back here, then you just connect the lines. Triangular prism, right there, okay? Well, what you're gonna do is you're gonna find the area of the triangle and just multiply it by, we call it the height, but you can call it the depth as well. And this is really how you find the volume of any prism. Just find the area of whatever the base is, and then multiply it by the height of that shape, okay? But also, not only prisms, but also pyramids as well, which is why we saw those on the bell work there. So pyramids, what you're going to do is you're going to find the volume of the corresponding prism, because of course pyramids could be different, and you're just going to divide it by 3. So prisms and pyramids have the same relationship as cylinders and cones. So whatever like if you looked at the base value of the pyramid and pretended like it was a prism with a specific height, you'd find that volume, but you'd divide it by 3. That's the volume of pyramids. So there's not like a general formula here other than something like this. Of course, we can make it more abstract by using variables, but hopefully this is a little bit more precise when we're getting used to this stuff. So to demonstrate a pyramid, right? So let's say that we'll just do rectangular just because they're pretty basic right here. And you'd have a pyramid like this, okay? Now, we'll say that the lengths here are 4 and 3, I guess, and then the height here we'll say, and we are pretending like my drawings are nice. I'll say that's 6 inches tall right there. Now, the formula says you find this volume of a prism and divide it by 3. So we're going to treat it as though it were a prism, which means that, you know, it'd be like saying, well, I got some action right here, and I went too far on that one, but you see what I'm saying, hopefully. So we treat it like a prism first, and this rectangular prism, so I'd say, well, 6 times the 3 times the 4. But yeah, no worries. I'll still finish. I hope that's okay. Yeah, the volume of this pyramid, yeah, I just actually canceled 3's, make that 24 cubic units, whatever the units are. All right, just a little quick review. Remember, this is just solving formula stuff. So this is the volume of a cylinder, which we know would be pi times the radius to the power of 2. And then we multiply that by the height. And here they gave us the radius at 21 millimeters. So I replaced the radius with 21. And I replaced the height with 19. Because they said right here that the height was 19 millimeters. And again, this is something we could put directly into the calculator. So I type pi times 21 to the power of 2 times 19, enter. And the calculator right now is showing me this, 8,379 pi. And yes, that would be in cubic millimeters. This is what we call the exact value. So just in case it asks for an exact value on an assignment, this would be exact. And I think we've seen this with area of circles. if we wanted an approximation, then on our calculator, we go to that double arrow button just above the enter button and push it. That'll change this into a decimal, which for me shows 26,323 point, I'm going to round it to 0.4, although it's showing 0.40484. And again, this is in cubic millimeters. Now on the assignment, it should specify that it wants these rounded to the nearest tenth. If it does, then we're looking at the approximation, not the exact value. But just in case it asks for exactness, then it wants the answer in terms of pi. Well, that was a little review from last time. Now we're looking at a composite shape right here. And what am I looking at? Well, I'm looking at a rectangular prism right here in the bottom. And then on the top here, see how that's half a circle right there? Which means that if it were a full circle, of course, it has depth, which makes it three-dimensional. This would be a cylinder, okay? And it may be hard to tell on this diagram what the depth is, but it's this 1.25 inches right here. Okay. Now, what I'm going to do first is I'm going to treat this as though these handles right here of the foam kickboard were filled in. So I would be trying to find the volume of this full shape, but without handles. Okay. Once I figure out that volume, then I can find the volume of the two handles. And see how they're empty, right? They're not actually filled in with foam. So I would have to subtract that volume of the two handles from the volume of those two shapes without handles, okay? So I'm going to work my way down on this shape. I'm going to start with the top here. That's again, that's a half cylinder. So let's go and put this in here. See if we can fit it anyways. Half cylinder. And the volume for a half cylinder is found by taking the volume of the cylinder, pi times the radius to the power of 2, times the height. But since it's half a cylinder, I'm going to divide this by 2. So whatever I get from this will be the volume of the cylinder. And this is, again, I've kind of manipulated the formula here is divide by 2. Again, because it's just half a cylinder. Half a cylinder divided by 2. Well, let's see, what values does it give us in this shape? Well, it's 2.5 right here. 5.5, sorry, is pointing to this dashed line in the middle. And that goes from the center of the circle to the edge, which means this is our radius right here. So I go to my formula, I replace my radius with 5.5. See if I can fit that in there. That works. And we also know the height of this shape. Again, that's this the depth of the full shape down here, 125. So I'm going to go back to my formula, height, and replace the height with 1.25. So this creates the formula. It's a direct calculation, which means I can plug it in to the calculator right now, and that will give me the volume of the half cylinder. So I'm going to use my fraction button, n over d. I type in pi times 5.5 to the power of 2 times 1.25. I go to my denominator, I put 2, I push enter. My calculator shows me 59.39573611. I'm going to round this to the nearest tenth, which makes it 59.39, so that'd be 4. 59.4 inches cubed. So that's my half cylinder. But now, I also have the volume of this. Again, this is a rectangular prism. I know that the corners kind of look curved there in the bottom. They're just going to treat it like it's a rectangular prism on this one. So let's find the volume then of the rectangular prism. There we go. And since that's what I want, the volume of the rectangular prism, it's just length times width times height, because it's rectangular. Length times width is the area of the rectangle, then the height is just the depth of this thing. And we already know the depth, by the way. The height, I'm going to say, is 1.25 there. So I'll replace that right now. But what about the length and the width? Well, it shows here the length. I'll say the length is 11. You could say 12, but it's not going to matter because order for multiplication does not matter. So my length that I'm replacing is going to be 11. And then the width, I'll say, is this 12 right here. So I replace my width with 12. And I'm just going to plug this into my calculator to see what the volume of that rectangular prism is. So in my calculator, I got 11 times 12 times 1.25, enter, and I get 165 cubic inches. All right, now this is two separate volumes, and I want the volume of the whole thing though. So I'm going to figure that out by adding these two together. So this is the volume of the full shape, but again, that would be with the handles filled. Right, so that would be the volume of the cylinder, 59.4. And then the volume of the rectangular prism, 165. And when I add these two together, that will be the volume of the full composite figure with the two handles filled in. So 59.4 plus 165. Some of you did that in your head, and that's okay. 224.4 cubic inches. Now again, this is not the answer because there's no foam where those handles are. So we actually need to figure out the volume of those two handles. And from there, once we get the volume of those handles, then we'll subtract those out from that volume with the handles, okay? So let's take a closer look. We put it here on the left so that it just has a little bit more space, okay? Now in this shape, let's take a closer look at this shape right here, okay? In this shape, we don't really need the rest of that, so I'm just kind of isolating this, right? I see in the middle, this part right here, that's a rectangle. We'll pretend like I outlined it very well. Now, since it's a rectangle right there, that means it's a rectangular prism. On the other hand, though, we have this half circle here. But if you combine it with this other half circle, it ends up being a full circle. Circular prisms are known as cylinders. So not only do I have a rectangular prism, but I also have a cylinder with it. Okay. Now it doesn't matter which one you start with. I'm going to start with the rectangular prism once again. And we've seen all these already, so we should be able to figure that out. The volume of our rectangular prism, length times width times the height. And the height on this one, again, that's going to be the depth of this shape. I know it doesn't show it on this one, but we remember that it was 1.25 inches. The width on this one, I'll say that it's this 2 inches right here. Okay, so I'm going to replace the width with 2 inches. You can say it's the length if you want. It's not going to change the value of our volume. But what about the length on this one? Well, I would look to the circle right here. And maybe hard to tell right there, but it's this line, this white line right here goes from the center of the circle to the edge of the circle. That's the radius. And you can see that the length of this rectangle is actually the same as the diameter of the circle. So, in order to find the length, it's the same as the diameter. I would take the radius at 0.6 and I'd multiply it by 2. So that would tell me the diameter is 1.2 inches, which means the length is also 1.2 inches. So I replace the length with 1.2 inches. And now I'm ready to find the volume of this rectangular prism of the handle. So 1.2 times 2 times 1.25, enter, and I get 3 cubic inches. Now again, that's just the rectangular prism part of the handle. We also have the cylinder. Need the volume of the cylinder. So the volume of the cylinder is found by taking pi, multiplying it by the radius to the power of 2, and the height. And the radius was already given at 0.6, so I can replace my radius with 0.6. R, radius, 0.6. And the height, again, that's the depth of this foam board, which, again, we know is 1.25 inches. So I can put this into the calculator. This will give me the volume of what would be a full cylinder, even though it's been cut in half but separated. So pi times 0.6 to the power of 2 times 1.25, enter. And I get 1.4137166694. But rounding to the nearest tenth would make that 1.4 inches cubed. Now remember, I want the volume of the full handle. So I would have to take the volume of the rectangular prism at 3 inches and the volume of the cylinder at 1.4 cubic inches, and I would need to add those together, which would be 4.4 cubic inches. Now do recall that this is one handle. I want the volume of 2 handles. So I would take the volume of one handle, 4.4 cubic inches, and just multiply it by 2. And this will tell me the volume of both handles together, 8.8 cubic inches. So we got 8.8 cubic inches, and we're going to take that 8.8 cubic inches and subtract it from the volume with the handles, right? So if I want the volume, which I do, volume where there's no foam in the handle, so without the handles. You can word that a little differently. I'm sure there's better ways to word that, but I'm just going to take the volume with the handles, 224.4 cubic inches, and the volume of the 2 handles, 8.8 cubic inches. And I would be looking now to subtract these. So I can do that in the calculator. I know some of you can do that in your head, but right now I can't for some reason, and this is 215.6 cubic inches. And that would be the volume of this foam board where there's those 2 holes punched out of it for the handles. So we see volume of composite shapes. You gotta find the volume of lots of different shapes right here. Like we essentially found the 4 different volumes and then combined them based on the shape that we're looking at. Sometimes you're gonna have to subtract these out like we did. Sometimes you're just gonna add those together. It depends on how it's formed and how it's, shaped. How it is shaped. All right, so there's our volume of the full shape. Again, that's without the handles. And we even rounded that, right? So it was, we said it was 215.6 cubic inches. So we're going to use this value. Now right here it says 1 cubic inch of foam weighs 0.007 pounds. How much does the kickboard weigh? This takes us all the way back to kind of the foundations of multiplication. Because each one of these, 215.6 cubic inches, each one of these is 0.007 pounds. Now this takes us back to the unit rate, or the rate unit. And you can solve it that way, but again, we should know that just from the basic foundations of multiplication, we're going to take 215.6 and multiply it by this many pounds. 0.007. Now we'll end up with a decimal on this, no problem. What do we get? 215.6 times 0.007. Enter, and my calculator shows 1.5092. That's not a bad decimal, and yeah, that would be in pounds, by the way. But like we did on the last problem, I'm just going to round this to the nearest tenth to make that 1.5 pounds. Rounded. Okay, so it's very light, but it's also not very big either, and it's made of foam. Apparently, pretty light foam. On this one, we have a cylinder stacked on top of a cube. You can call it a rectangular prism if you'd like to, but I'm going to call it a cube. How do I know it's a cube? Because the length, width, and height are all the same measurement, 5. So I'm going to find this like we're solving for a cube. You'll get the same answer if you treat it like a rectangular prism, though. But I'm going to start by finding the volume of the cylinder. So I'm just focusing on one shape at a time. Start with the cylinder, okay? Now, to find the volume of a cylinder, we're going to take pi times the radius to the power of 2, and then multiply that by the height. And on this one, right here, this red line, see how it goes through the center from one edge of the circle to the other? That means that we're actually looking at the diameter. So, if I want the radius, which I do, I got to take that diameter, 4, and divide it by 2. that tells me my radius is 2 inches. So now I go into my formula and I replace the r radius with 2 inches. And then I see my height here at 4 inches, so I replace h, my height, with 4 inches. And yeah, this is just a formula that I can use for the volume. So I'm going to plug this into the calculator. Pi times, I put another h there, didn't I? I meant to put a 4 there. It's like an upside down 4 almost. Pi times 2 to the power of 2 times 4. And I get 16 pi. I don't really want the exact answer on this one. I'm going to round to the nearest tenth. Push the double arrow button just above the enter button. And that shows me the volume is 50.26548.246 on my calculator. Rounding to the nearest tenth makes that 50.3 inches cubed. Now that's a cylinder. Not only do we want the cylinder volume though, we also want the volume of the cube. So the volume of the cube is where we take the side lengths, which are all the same, they're all showing us 5, and we just raise it to the power of 3. So that tells me that the volume here is equal to 125 cubic inches. You can type that in 5 times 5 times 5, or 5 to the power of 3. Either way, you'll get 125. Okay? Now we want the volume of the full shape. So full, I'll write this down as full volume. Not that you have to, but because we should know that. But that means I'm going to take those two volumes. Cylinder, we'll start with 50.3. And then I would be adding the volume of the cube, 125. You can put that in a calculator if you need to. Doesn't really matter. Still going to be 175.3 cubic inches. That'd be my answer. So this really is not different than what we did in the last lesson. It's just you're looking at two different volumes in this particular problem and just adding the two together. That's it. All right, here's a cone. Not only is it a cone, but it's an ice cream cone. Now they're not showing the scoop of ice cream that's on top. However, they did say down here that we get to treat this as a half sphere cone with a radius of 3 centimeters right there. So, 3 centimeters. And they even give us the volume of a sphere. Remember, it's never really required in this class you memorize these formulas because we have posters in the classroom with these, okay? Now, there's a couple measurements on the cone we have to be aware of. We only need one of them. We'll go over that. But, however, I'm going to start with the half sphere first. You don't have to, but I'm going to because I like to work my way down. Like if this was an actual ice cream cone, I would definitely eat the half sphere first, okay? I guess I don't know anyone that does that backwards. You know, it's not like a stuffed crust pizza. Anyways, maybe you have, I don't know. I just never have seen someone do it, that's all. Actually, I've seen babies do it. Anyways, that's a half sphere, right? So I'm going to look at the volume of a full sphere, which is 4, and again, I'm writing this a little different than the formula right there. 4 times pi times the radius to the power of 3, all divided by 3. So we got the radius right there. However, this is a half sphere, so I can put this as divided by 2. And I can plug this directly into the calculator just the way we see it. I just need the radius on this one, and they gave it to us down here, 3 centimeters. So I replace the radius with 3 centimeters. I type this into the calculator, and that will be the volume of this half sphere. So again, I have this written as a fraction, so I got the n over d button first. 4 times pi times 3 to the power of 3, all over 3. And then I get out of my fraction, and I put divide by 2. I push enter. Now again, this shows me 18 pi. I don't really want the exact answer on this one. I would prefer the decimal, so I push the double arrow button. I get 56.548667776, which I will round to 56.5. And what are we looking at? Centimeters cubed on this. So there's my half sphere. But I also have the cone. Let's go and find the volume of the cone as well. Volume of a cone, no problem. Pi times the radius to the power of 2. I should have written that smaller. pi times radius to the power of 2 times the height, all over 3. And the radius on this one, shown up here at 2.5. So there's my 2.5 right there. Gets a little sloppy. Now these other two measurements down here, okay? I got 11.5. That's the slant height, which we would use for surface area, but we're using volume, which we need the actual height. So whenever you see this, the height, just understand that the height needs to go from the center or the tip of the cone to the center of the circle in the cone. It will not go along the edge right here. So actually, I don't even need that 11.5 right there. But I do need the 11.2 height. And this is a full cone, so I can solve this directly. So I type in my calculator, n over d, pi times 2.5 to the power of 2 times 11.2 all over 3, enter. And it gives me 73.30382858. So I just say that's 73.3 centimeters cubed. Of course, we're going to add these two together, which is going to give me the volume of the full ice cream cone. 56.5 plus 73.3, enter. And I got 129.8 cubic centimeters. Here's our objective. I can find the volume of composite shapes and spheres. Of course, maybe that's a little redundant right there because spheres are shapes. But we should feel pretty good about that right now.